All right. So the basic premise of everything in Unit 9 is very, very similar to what we did in Unit 7 and 8. Okay. So what do you guys think? Let's kind of go through. Do you guys think students are more likely to drink more water than teachers do?
No. Yeah. Like as a whole?
As a whole. Per person.
I think probably, yeah.
No.
No,
I don't think so.
No.
There's no way.
No.
I have no idea.
I have no idea either. Yeah.
It's teachers.
But are you with me that what we would, in order to answer this question, we would need to take 2 samples?
Yes.
So we would have 2 imperfect samples, yes? Is this okay? All right. Are Ohioans more likely to eat ice cream than Michiganders?
Yes.
We have better ice cream, no
It's
question.
just cold too. Colder.
Yeah.
It's boring.
So how do we decide if 2 different populations are different from each other? We take 2 samples. And the big idea behind this idea of when we have 2 samples means we have more like innate variability. Remember how we talk about samples aren't perfect, right? So if we all took a different sample from the same population, we'd have variability in our samples. And then now if we took from 2 different populations, we have more variability because we're sampling from twice as many stuff. Okay? So when this happens, we need to use a different procedure, but it's a very, very, very similar procedure. Okay? So the first one we're going to talk through for 9.2 is, so we're focusing today on what happens when what we have are 2 different proportions. Okay? So steroid testing for 40 randomly selected softball players showed 15 positive results and 9 of 30 weightlifters. Okay? So do we have 2 different populations here?
Yes.
Yeah, what are my 2 populations? Softball players and weightlifters, yeah? So are you guys with me that we can kind of say this means we actually have 2 different p-hats? Are we comfortable with that idea? So what I'm going to do is I'm going to make one of these p-hat S for softball players, which is 15 out of 40, yeah? And then 9 out of 30 for, and we'll call that p-hat W for the weightlifters. And so if we just kind of do some real quick. Okay, so you guys, as we look at our 2 samples here, it looks like steroid use is more prevalent with softball players than with weightlifters, according to our samples. One is 0.375. The softball has 37.5% of the sample, right? And the weightlifters had 30% of the sample. So we see some difference between the 2 groups in terms of their percentage. Is that convincing? Is that difference big enough to convince us that one group is bigger than the other?
No. Yes.
We don't know yet.
That's the best answer. We don't know yet. There's so many things that we should consider. So rather than just trying to use our own gut instinct, that's why we run the test. Okay? Now, the hypotheses for this is going to be a 2-sample test. Okay, so what are some things that we need to know here? Let's see, we've got alpha equals 5%. I don't know why I'm in a highlighter. Alpha equals 0.05. Okay? What should our hypotheses be about? Like as we think through, convincing evidence that the softball is more prevalent, right? Are you guys with me? So that would be that the proportion for the softball team is bigger than the proportion for the weightlifters. Are we comfortable with that? What would that make my null hypothesis? That PS is less than or equal to PW. Now, just because I want to make sure I'm very clear in my expectations, okay? You guys, do you see these subscripts? Do you think it's reasonable for me to expect that you use some sort of subscript to help identify which one's which? Because you can't just do P is greater than P because that doesn't make sense. Okay, do you guys see what I'm saying? But if you use like PL for a lifter, that's fine.
Do we have to do like a key? Like S?
I'll be able to get it from this. Like when you, I think that would be sufficient. Okay. Everybody good? Great. So from here we have this alpha equals 0.05 and we have to decide, and this doesn't specify whether or not we're using the rejection region method, that traditional method, or the p-value method. I'm going to show you both because it's really, at this point, the same thing. You guys, when it was proportions, did we use Z or T? Z. Proportions were always Z. Okay? And so which Z's will make us reject the null hypothesis? So when it's Z, we use the inverse normal. Which is this, a right-tailed or a left-tailed test? Right-tailed, and I know that because the alternative hypothesis is a greater than. So I'm going to show you to the right. And what do I know about that area? 0.05. And what are we getting? I can guess that it's 1.645. Okay. Are we feeling okay? Not feeling okay? Inverse norm.
Yeah, I'm not confused. It actually takes like 30 seconds to get the right music. Once you got it, yeah, I actually sat.
I mean, you end up like, it's a 50-50 chance right now which menu you're going to use, right?
Like it actually takes me so long just to get it. Oh. My phone's just plugged in.
All right. Now, you guys, there's also a component, I want, real quick, are you guys with me that I could rewrite these? Another way to write these hypotheses would be like PS minus PW is less than or equal to 0. Those are equivalent statements?
Yes.
Okay. So if for some reason you had to calculate that Z statistic by hand, this is the formula you use, where so we would put like the P hats here and the 0 here as the hypothesized value. If for some reason you use your formula sheet to calculate it by hand. But that being said, you can use your calculator, so I'm going to show you how to do it in the calculator real quick. Okay? All right. So all right, so you guys, to come up with our actual test statistic, our Z statistic, and our p-value, you're going to go into your calculator. let's do this. So I'm covering everything up here. Okay, you're gonna hit stat. You're gonna arrow over to tests. Which one do you think we should pick? We're not gonna pick the 2 sample z-test. No, we're not doing the 2 sample z-interval. Because this is about a proportion, we're gonna pick 2 prop z-test. Is everybody with me? Why two samples means it's a 2 proportions. So we're doing a z-test about 2 proportions. Okay? So 2 prop z-test is option number 6. All right. When it asks for x1 and n1, it does matter which one you put in first. Which one should we put in first? S, the one that we wrote first, yes? So 15 and then 40, okay? And then 9 and 30. Make sure that we have the greater than sign. You guys, I found that our z statistic is 0.654. And just because we're going to use it in a second, our p-value is 0.256. What did you get?
Yeah, laugh now, cry later. It's because you put 9 over 50. It's 9 over 30. Oh.
Everybody good?
Yep.
All right. So our z statistic, the 0.654 is like here, yeah? If that's the case, are we rejecting or failing to reject?
P-value I got 0. Wait, for my P-value I got 0.2. Yeah, so same here.
That's what I got. I don't know why you guys always argue with me. That's what I got. You can see it on my calculator. I just,
Yeah.
Yeah.
Wait, so
Are we rejecting or failing to reject?
failing.
So this tells us fail to reject because it's not in the region, right? And then this one, my p-value is greater than that alpha value. So this would also tell us to fail to reject. Both are going to come to the same conclusion. Speaking of, we should probably make that conclusion regarding the claim. We do not have enough evidence. To say softball has higher prevalence of steroid use. Than weightlifting. How do you guys feel about this? It's pretty much the same thing, right? The only difference is which one you pick in your calculator. Cool? Let's look at another example.
Why is it greater than? Because I clicked P2 greater than
Say that it,
P. So, which one is it? It's greater than P2.
it's always going to match your alternative hypothesis. Because you're basically saying P1 is greater than P2.
Okay. Because you're using the alternative.
You always, that's always asking for the alternative.
Honestly, it takes me a while to figure out how to fit it to me.
Wait, why was...
Okay. All right. Everybody good? What are we seeing here? Some things that might jump out at you. The sample size of men and women. So essentially the p hats we have will be for men and women. Are we comfortable with that idea?
N equals 200 for men. And 113 for X. For men. 175 for N. Confidence interval.
So we're not going to write hypotheses. Yeah? We just need to get the interval. All right. So this time what we're going to choose is 2 prop z int. So go ahead and open up 2 prop z int on your calculator.
So we don't
do you
even
not
need-
even, yeah, do you not need to find C? Or, like, do you not need to make the interval?
All right, so in theory, so
Oh, yeah.
yes, like what your calculator does all of it
Okay.
for you, and that doesn't seem like something I'm going to be super duper picky about.
So wait, what are we doing again, the calculator?
So you're going to go stat, you're going to choose the 2 prop z int, which is further down.
Alright.
All right, so we're going to,
Wait, can you zoom in? Sorry, I cannot see that.
okay, and I'm telling you for the difference of proportion men minus women, so we are trying to estimate, we're trying to estimate PM minus PW. That's our goal in this particular one. So for my X1, I'm going to put 113 out of 200, and then 83 and 175.
I already have a 0.9 confidence interval. Wait, just like 0.9.
All right. So guys, I'm seeing this interval as 0.00598 to 0.17545.
Oh, okay.
Are we all comfortable with this?
Yes.
All right. Now, some other things I want us to consider about this. You guys. What is the center of this interval? Another way of saying that is, what is my point estimate? Right? Because the center of the interval is the point estimate. 0.084. Okay.
735.
So 7. I'll just take it out one more. Okay, that's fine.
Because you
You would add them together and divide by 2.
Add them. No, I subtracted.
And then you would add 0.00598 to it. Because otherwise you just found the...
Subtract the biggest one.
And then divide by 2.
That'll tell you what the margin of error is.
Oh, so that's wrong.
0.09075.
Yeah.
Point
So
zero.
when I
Hold
do-
on.
How do you do the margin of error again?
Margin of error is small, biggest minus smallest.
Okay.
Point zero nine
What
zero
again?
seven one.
0.0907.
Great. Great. Okay.
What does it represent?
So that's why I want to talk about it. Okay. Is that the percentage of either sample?
No.
No. Are we trying to estimate the percentage of either sample?
No.
No. We're trying to estimate the difference. Is everybody with me? So can you guys help me out? Some people figure out what is 113 out of 200, and some people figure out 83 out of 175 for me.
13 out of 200 is
0.565.
Point. And you guys, what do you think the difference between these two values are? Our samples suggest the difference is around 9%. Yeah. That's what our samples suggest. Right? Now, what do we know about our samples? They're not perfect. So we give ourselves this wiggle room. So when we do this interval, I don't know why it keeps doing that. Okay. So when we do this interval, and if I ask you to interpret this interval, we would say with 90% confidence, the difference in proportion of men minus women who approve of the president is in the interval .00598 to 0.17545. It's somewhere in that interval is the actual difference between men in percent of men versus women. So the goal of this interval is not estimating a single proportion, but rather is estimating the difference between two groups. Is everybody good? All right, you guys. Can we say there is a difference between the two?
No.
Justify your answer.
Margin of error small.
Okay, does anybody want to come up with a different answer?
Not a big enough sample size.
Sorry, thanks for playing. You would use the interval to make this decision, you guys. So looking at the interval itself of all the possible values, can we say that there is a difference?
Not enough evidence.
Yes.
Justify your answer.
I'd explain it.
You guys, so before we decide is there a difference or not, can we say that there's a difference?
Yeah, because the interval is different.
You guys,
It's not the same numbers.
what would it mean? Could we say about PM minus PW if there's not a difference between the two? Okay.
That is my point.
Is 0 in the interval anywhere?
No.
No.
So is it possible that there's not a difference? No, because 0 is not in our interval. It's not one of the reasonable values that we just calculated for the difference. And so if I'm looking for a difference between two groups, it's always going to be 0. If 0's in the interval.
So if it was like 0, 0.1.
Well, so it might be like negative 1 point or negative 0.21 to positive 0.3. If that were the case, zero's in the interval. The fact that in fact, we can also kind of look at this and say, hey, the whole interval is positive, right? What does it mean about this difference if the answers are positive? It would mean that PM would have to be bigger than PW, yes? So our interval suggests that men are more likely to approve of the president of what the job, however the wording it is, feel that the president is doing a good job. It's a higher proportion of men than women. And this is now beyond the sample. We can make this conclusion. Is everybody okay?
So 0 has to be in an interval to say that there's a difference?
No.
Oh.
If 0 is in the interval, it's possible that there is no difference.
Oh.
So if 0 is not in the interval,
Oh,
there is
I
a
wrote that on
difference.
my paper, but maybe I just said it wrong. We're saying no because 0 is not in the interval. Or did I mess that up?
So we're saying yes
Oh.
because 0 is not in the interval.
Oh, just change that. Yeah. All right, got me all messed up. There is a difference if 0 is not.
Yeah, because no difference would be that the difference is 0.
All right, I'm gonna need a second to think about that. Do that sometime. Yeah. Start studying now. Maybe I'll get it by then.
You guys, if this had been a test instead, my null hypothesis would be, or my alternative hypothesis would be not equal to. We're just trying to say there is or isn't a difference. Is everybody with me? Making my null hypothesis equal to. So if I had asked you to do this with a test instead of an interval, this is what it would look like, yes? Okay, and for 90% confidence, what would that tell us about alpha? What alpha would go with 90% confidence? Well, alpha would be 0.1, but you are correct in that the tails, it would be two-tailed, so the alpha would still be 0.1. Okay? And let's use just the p-value method to do this. If we go to do this one in our calculator, I'm just going to use the other one. You guys, if you put these into the 2 prop z test, what is your p-value?
P-value?
0.079.
P-value.
Yeah.
Which is less than 0.10. Yeah? Are you guys with me that this is the exact same thing? So you can use this confidence interval to test if there's a difference, just like you can use a test to test if there's a difference. Okay? And I'd argue that the confidence interval gives you a little bit more information. Yeah. Everybody good?
Yeah.
So that's just saying that it's not equal, right?
Yeah.
When the
Yeah.
equals.
Everybody good? A confidence interval, like the question was, is there a difference? Yeah.